Alright, what's up, geometry peeps? Today we're going to look at similar triangles and parallel lines. We're going to start with our first theorem. And the theorem states, if a line is parallel to a side of a triangle, the intersected sides are divided proportionally. Proportionally. Again, that's the key word there. So what that's saying is if, let's label our triangle real quick. A, B, C, D, and E. And we're saying, hey, these two lines are parallel. So what the theorem says is if those two lines are parallel, okay, parallel to a side of a triangle, the base of my big triangle being the side, and the intersected sides are divided proportionally. So by intersected sides, I mean these two and these two. Alright, so because we have parallel lines, we have corresponding angles congruent, which means that this small triangle is similar to the big triangle by angle. But this theorem allows us to kind of skip a step and make our life a little easier because it divides the sides proportionally. So earlier we learned that we could do the small triangle to the big triangle and match up our pieces that way. But now our theorem is saying, well, it divides it proportionally, so check this out. So I can actually go AD over DB is equal to AE over EC. So what that says is this parallel line cuts the sides up into equal proportions. So we went top over bottom equals top over bottom. You could also go left over right equals left over right. So I could go AD over AE is equal to DB over EC. Either way is fine, either way is consistent, and either way works because we have equal proportions. Alright, so let's use this theorem and use this fact to do some examples. So let's take a minute and set this up. So I'm going to go A, B, C, D, E. I'm going to say AD is 4, DB is X, AE is 10, and EC is 15. And of course, you are given that my lines are parallel. Alright, so the directions here would say use the diagram to solve for x. So again, we know we have parallel lines, therefore the sides are divided proportionally. So I'm going to go top over bottom equals top over bottom. So 4 over x equals 10 over 15. Once I have my equal proportion set up, go ahead, cross multiply and solve. 4 times 15 equals 10x. So 60 equals 10x. X is 10, and that's that. Alright, so number 2. Let's set this guy up. The directions are going to say find AC. So we want to find the measure of the length of AC. We're going to call this ZACHR. And R is going to be 3. AC is going to be x minus 5. RH 15. CH x plus 3. Okay, and of course we are given my parallel lines. So now we got to set this one up. So again, I'm going to go 3 over 15, x minus 5 over x plus 3, top over bottom, top over bottom. You could go left over right, but I'm just going to do this one. 3 over 15 equals x minus 5 over x plus 3. Cross multiply. So 3 times x is 3x, 3 times 3 is plus 9, 15 times x is 15x, 15 times negative 5 is negative 75. Alright. Then move my 3x, I get 12x. Add 75, I get 84. Divide by 12, and x is 7. And that worked out pretty. But we are not done yet. It says find AC, so we have to substitute in my value for x into AC here to find that value. So if x is 7, 7 minus 5 is 2. So AC equals 2. Alright, so those are some easy examples. Now let's have some fun. The third and final example, I'm going to tell you we have parallel lines. I'm going to tell you this piece is 2. This piece is a little longer at 3. The base is 3x plus 1. and the base is 2x minus 2. Now, we said it divides the sides proportionally, so these two sides and these two sides, but this time you were given the base of the triangle. Now, when you're given the base of the triangle, you have to be very careful because we have to do this one old school style. We have parallel lines, so I have corresponding angles congruent, and then I'm actually going to take the time to redraw my triangles because we have the little triangle similar to the big triangle. Alright, now we have to decide what's the length of this side. Is it 3? No, because 3 is just here. It's kind of like the length of that trapezoid there, right? And we're dealing with the whole triangle. So I have to deal with this whole side. So I have to go 2 plus 3, which is 5. Alright, so don't let that trip you up. When you're given the base of these triangles, you can't use the little theorem. You have to do it the old way. So I have, let's go side over side. So 2 over 5 equals base over base. So I went little side over big side equals little base over big base. So again, I was consistent, and that's why this works. So 6x plus 2, I distribute my 2, distribute my 5, subtract my 6x, add my 10, and x is 3. So it said, if the direction said solve for x, we'd be done there. If it said find the measure of a segment, we could substitute in that value and find the other ones. Okay, 6:35, bye.